In this video, we're going to be looking at what scientific notation looks like in the calculator. And I call it, and the students know it as the power of E, because that's what our calculator is going to tell us. So for instance, say you're teaching 8th grade math, you're doing scientific notation, and a student wants to be able to convert a scientific notation problem on a STAR test or on a question that they're working on. Well, if it's a small decimal strand, then you're going to be able to do that in a calculator real easily. Let me just give you an example. Let's say I had 3.52. And I put that in times 10 to the power of, let's say, -3. So if we have one like this, the student can actually put it in the calculator, hit enter, and notice it will convert it, right? And you'll get your decimal strand right there. Where you run into an issue is when the number's a lot bigger. So let me give you an example. Let's say we did 3.52 again, and we multiply that times 10 to the power of -18, right? That's a really large number, but they could run into something like that. And you hit enter, and notice it gives them this e to the -18. Now, why this is really important, and I would say in algebra this becomes important for them to know when they're working on exponential regressions and they're making predictions with future values where things can get up into the millions. Even exponential growth and decay, we run into this a lot, where the students will solve a problem and they'll get an answer in the power of e, and when they see that, they'll get confused and they'll say, hey, Mr. H, something's wrong with my calculator. It has an e in it. And so it's good to go ahead and explain to them when you're doing exponential functions in algebra or scientific notation in 8th grade math that this e just represents times 10 to the power of something, and tell them that the power, right, the exponent comes after the e. And that's what I usually tell them. And to give them an example, I always show a few examples. And I say, well, you know what? Let's say we had 0.00367 5, and hit enter and say, look, it automatically converts it to scientific notation. And once again, they can actually put in a decimal strand that's on a STAR question on some cases if the power is great enough, right? If the exponent is great enough, and it'll go ahead and convert it for them so they can pick the right answer. On the other hand, if they get an answer like this when they're doing exponential growth, then they know that they just have to move that decimal, right, 14 times. And I say this would be exponential decay. But whether exponential growth or exponential decay. Let me just give you an example. Let's say they have this huge number. Let's just going to put random digits in here, really large, right? And let's say they wanted this to be scientific notation. Well, they could go ahead and hit enter and nothing will happen, right? It just repeats the number. However, what I found is if you go back in there and you put a decimal after it, and then you hit enter, it converts it to scientific notation for you. So you can actually use this calculator to convert it to scientific notation, providing that there's enough digits inside of your number. So there's a limit to that. And just so you're aware, the values that you have to put in, you have to put at least 7 digits. So this only works with 7-digit numbers. For instance, I could do 1, 2, 3, 4, 5, 6, 7. And then I could put a decimal, hit enter, and notice it's going to go ahead and convert it. And this is 3.33333 times 10 to the power of +6. And that's what they need to know about scientific notation and how it's notated in the calculator. So it can be useful for them on their test and when they're working on problems that have huge numbers or really small numbers.